What I've got is I brought in a cylinder. And this cylinder contains, I've got to cover up the whole the name and everything, hey, otherwise I get sued. But you can see that it contains chips. Here's a question. Does it really contain chips?
I think we're going to have to test it.
Have I already eaten the chips? So let's do that. Okay?
That would just be
We're going to open it.
Well, the seal's still there.
The seal is still there. It contains chips. And apparently, hey, these are like really phenomenal. They're very good.
Looks delicious.
They really are. Would you like one?
Yes,
no.
please.
Okay, but I need the container. So what I'm going to do is I'm going to empty all these chips in this container.
Like I hold your map. I'll hold your chips.
There we go. You can have the chips. That's the end of my chip.
Right. What do you want one?
So
later.
What we've got now is in this cylinder. Please take note. It looks complicated to find the surface area, doesn't it? But it's actually got a circle, and then it's got another circle. So in other words, to find the surface area of a cylinder, we start with two circles. Now guys, you can all find the area of a circle. It's just, the area of a circle is pi times r squared. Okay, we did that last week. But now we've got this whole complicated round thing. So I'm going to show you what this round thing actually is. Now I brought in a pair of scissors.
These are delicious, Peter.
I'm glad. And what we're going to do is we're going to cut this up. Right, so let's go for it, and I'm going to do it so the camera can see it. And I'm painfully cutting a hard cardboard box with blunt scissors, which is quite interesting. Here we go. Okay, and I'm just going to get rid of the circle somehow. There we go. Right.
You're doing well.
Am I?
Look at that, yeah.
Okay, there we go.
I thought you were never going to get through there. I was like, let's
Where's
see.
your faith? All right, so over here now you can see the other circle and the top circle, which was the plastic lid. Now watch carefully, folk. Here's my cylinder. Look what happens when I open it. Voila. I actually land up with a rectangle. There it is. And that's the fascinating thing about a cylinder. You know, when we got told or asked to find the surface area of a cylinder, we think, oh, this is going to be so hard. How do I even start? Well, all it consists of are two little round circles and a rectangle that's been folded up and go around, and there is our little cylinder. Okay? So let's go back to the board. In fact, let's not even do it. Let's do this for real life. I think let's make Maths Lit is about real life. This is what we're going to do. So the first thing I'm going to do is I'm going to measure the diameter of my circle. Okay? Or measure, or try and work out the area rather of my circle. So we're going to pretend that this whole cylinder, which I've cut up and totally annihilated, we're going to pretend that we're going to paint it. And I want to know what surface area am I going to paint. So let's do that. First thing, the circle. Now, our formula for the area of a circle is this. Pi times r squared. So we need to know the radius of our circle. I'm not going to work out the radius because when I look at this tin, I'm not going to be 100% accurate. Let me show you here. I'm not going to be 100% accurate. I'm not going to know exactly where the center of that tin is. So what I'm going to do though, I'm going to cheat a little bit. I'm going to measure the diameter because a radius plus a radius is a diameter. So once I've got the diameter, I can divide it by 2 and I've got the radius. So let's do that. So with my little ruler here, I'm going to, oops, I've nearly knocked this whole thing flying. I'm going to measure the diameter and I actually land up with 65 centimeters. Okay, are we going to write this down and measure it?
I will.
Okay, not 6 centimeters. Sorry, it can't be centimeters because then we'd be off the screen here. 65 millimeters. Okay.
Got it.
Don't know why I said centimeters. I think it was that chip. It did something to the brain.
I think it's just jealous because they're right next to me.
All right, so if you can remember that. Now what we're going to do is we're going to take this rectangle and I'm going to try and measure the length and the breadth of it. and we've actually got 220 millimeters. We're going to work with millimeters today, I think.
Good job.
Okay, have you got that?
220 millimeters.
Right. And then the length of it, we're going to measure that as well, and we get 205 millimeters. Okay. Now, I might be a little bit out, because if you look along here, I've actually cut this all funny. It went skew. But I think this measurement to here is more accurate, and let's just confirm this measurement of 205 millimeters this way. You know what? It's so close, we're going to take it.
Fantastic.
Okay. If you can remember that, then I'm going to go to the board and we're going to actually try and calculate the surface area of the cylinder. I think that's a great way to do it.
Yes.
Okay, let's do this. So, looking at this now, we're just going to extend this page a bit. Oopsie, there we go. Now, my surface area, first of all, I've got the two circles. So I've got 2, there we go, I've got 2 times, what's the area of a circle? The area of a circle is pi times r squared, okay? Plus, I'm going to work out the body part, this rectangular part, okay? And we said that was a rectangular, so to calculate the area of that, it's length times breadth. So let's do it. Plus length times breadth. Okay. Now, folk, in the exam, in matric, your examiner will tell you that pi is equal to 3,14. If you push pi on your calculator, you're going to get an answer of 3,142 something, 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 and the examiners are saying, you know what, guys, at the end of it all, we're going to round off anyway, so let's just round this pi off. So pi is 3,14, and the exam will tell you that. It'll say, let pi equal 3,14. So I've got 3,14. Multiply by my radius. What was the radius of this? First of all, what was the diameter?
It was 65 millimeters.
65 millimeters.
Millimeters.
Okay? Millimeters, eh? So 65 millimeters. Now, 2 weeks ago, we had Dolly who wrote to us. I remember that name quite clearly. And Dolly said, is radius squared the same as 2 times radius? Well, it's not, eh? Let's look at this. If we're saying radius is just, let's use a number 10, just for the sake of doing that. Radius squared would be 100. We discussed this last week. 2 times radius, 2 times 10 is 20. So a radius squared and 2 times radius is not the same thing. And 2 times r is a diameter. So we can't say r squared is 65. No way. That's not allowed. Thou shalt not do it. There are 11 commandments. Okay? Thou shalt not kill, thou shalt not this, and the 11th one should be, thou shalt not make r squared equal to 2 times r. Right, so let's move on. Calculator. Ooh, we've got a big calculator today. Right, so we're going to say 65 divided by 2. And that's going to give me my radius, and my radius is going to land up being 32,5. Okay, so 32.5. And we're going to square that. Plus, what was the length of my one side?
The length was 205 millimeters.
Right, so we got 205 millimeters, and the breadth was?
220.
220. Okay, so we can see we've got a mathematician who's not a mathematician here, because the length is normally the longer side. All right, so in the end, the length would be 220 and the breadth would be 205. But
Thank goodness you are.
Okay,
Thank goodness you are.
Right.
Hey?
So we're not going to question it. We're not going to. You never question a lady, guys. I know this is maths lit, but let me give you some life skills here, guys. You never ever question a woman. Okay? If they say do this, you just do it. So if she says, or if Indiana says the length is shorter than the breadth, then we let her believe it. But you and I know that's not the case. All right, so now we're going to take out our huge calculator and we're going to try and figure all this out. So let's try and do that. I'm going to have to go backwards and forwards because I'm not going to be able to remember all this. So here we go. We're going to say, first of all, clear that, and I'm going to say 2 times pi, which we said was 3.14, multiplied by my radius, which was 32.5, and we're squaring that 32.5, and we're going to land up now with an answer of, I'm never going to remember this, I hope you are, Indiana,
Okay.
6,633,25. Okay, so
333,25.
6,333,25. Okay, so that is, no it's not, 6,600. Oh, yeah,
That's what I said,
Guys,
you know?
it's hard to work when the help is bad, eh? Okay, so let's try that. Let's get rid of that.
I think it's for yours.
6,633,25 plus, now let's work out that rectangular part of it, and we're going to say 205 millimeters multiplied by 220 millimeters, and we get an answer of 45,100. Okay, so 45,100 what? Millimeters squared. And guys, that's the other thing I failed to mention, hey? When we're dealing with area, our units are always squared. And if you remember correctly, early on when we were measuring these things, we actually used millimeters. So my answer has to be in millimeters squared. Later on, when we tackle area questions, our answer is going to be in millimeters cubed. But enough of that now. Let's just carry on here. So here now I have this 45,100. To that I've got to add now 6,633. So plus 6,633.25, which means my whole surface area is 51,733.25. Okay, let's write that down. 51,733. Okay, let's just get rid of that again. And it looks like I've done exactly what I did last time. Okay, there we go. So now we've got, what did I say it was?
51,000.
51,000.
700. Oh, sorry, no, sorry. Wait, which one am I giving now? Is it the 51,733 and 25 cents?
733 and 25 cents.
You know, Peter, I've got so many of your numbers here. I get confused. I've still got the 45,100 from earlier.
And that confused you.
You could get some funny answers right if you're listening to me.
Right. Now, there's a problem with this whole question. Ladies and gentlemen, if I'm in an exam and I give you a cylinder like this, okay, and I say calculate the surface area of it, you cannot rip this off a piece of paper because the paper is flat. Okay? There's no 3D object. They're not in an exam going to say, right, folk, here is a cylinder, calculate the area. And you can't sit there and say, thanks, here's a cylinder, let me take out my scissors and cut it all off. Not at all. What they're going to actually do is they're going to give you a picture of the cylinder. So they're going to say, right, here's a cylinder with a top, and the cylinder is a little skew, sorry about that. And they're going to say, calculate the surface area of that. And all they're going to do is they're going to give you the height of the surface area, and they're going to say it is, what was our one height?
220, no, hold on.
220.
Yeah,
there we go. Okay? And then they're going to say the radius is, and our radius was 32,5, if I remember correctly. Mm-hmm. Okay? So they're going to give you the height and the radius. That's all they're going to give you. And then they're going to say, right, calculate the surface area. Now, guys, I've got a problem. I can't get into this and cut it up. So now we've got to say, sheesh, how do we do this? Well, the first thing is the circles are easy, aren't they? Because the circles are still a circle. And I know that the circle, I've got two of them, is going to be 2 times 3,14 multiplied by the radius, which is 32,5, and we're squaring that. Okay? That hasn't changed at all. Straightforward. So how do I calculate the area of this whole part? Right. We know the height. Okay? Now the height is the same as that length Do you remember? We measured this and it was 220. So that hasn't changed. So my surface area is still 220 multiplied by the breadth. Okay? But we don't know what that breadth is. But what we do know is this, and I'm going to turn to our cameraman again, right? So over here now, we've got the length, but we don't know what it is in the exam, but look at this. Don't you agree that my length, or the breadth of the rectangle, is the same thing as the perimeter of my circle? Can you see that? Let's look at it again. The breadth, okay, is the same as the circumference of my circle. Wait, now that makes life a lot easier, because we know that the circumference of a circle, and we discussed this in our very first program on the series, so we discussed it 2 weeks ago. How do we work out the circumference of a circle? It's 2 times pi, which we know is 3,142, times the radius, which is 32,5. Okay, now let's use all these new calculations and see if we come to the same answer that we did when we did it from a practical point of view. Okay, so I'm going to put this down there and let's carry on. All right.
And Peter, I do know that we do have fancy pictures that we've taken of all of your products in the next slide.
Is it the next slide?
I think so.
I think it
I hope
was
so.
this slide over here earlier.
No, it's fancy
it's the next
pictures.
slide, isn't it?
Fancy pictures.
Fancy
Fancy,
pictures.
just for you. No, yes, there, look. I know
think
it,
it was
but that's
the
not
very
what we're
next
talking
one.
about.
Here we go.
There you go.
Right, there it is. There's my container. So, great. So, we've got the height and we worked out all that. So, let's just go all the way back now to what I wrote earlier. Okay, oops, now we've gone totally wrong again. Okay, here we go. That's totally wrong as well. Now I've lost our place. You know, things are going so well, and then we have someone interfere, and then the whole life goes wrong again. All right, here we go. Here it is. Okay. So let's do this calculation, folk. We are now going to say, right, with my calculator, 2. Okay. Clear the calculator, and I'm going to say 2 times 3.14 multiply by 32.5. We're going to square that answer, and we should get the same that we got last time of 6,633,25. So let's write that down here now. 6,633,25, and we were dealing in millimeters, so my answer is millimeters squared. We've calculated the area just of the 2 circles. Now, let's calculate the area of the rectangular part, but remember this time we didn't measure it, okay? We used the circumference as the length of our one side. So on our calculator, up it comes again, and here we go. We're going to say, what are we going to say? Let's just have a look here. 220 multiplied by 2 times 3.14, let's leave it as 3.14, don't worry about the 2, multiplied by 32.5 equals, and now we get an answer of 44,900, okay? So it's going to equal 44,900, okay? And 902 rather. Okay, so now folk, let's add the 2 up and see what we actually get. Right, let's get a pen, shall we? Right, let's add those 2 numbers up and see what our final answer is. Plus our 6,633.25 equals, and my answer works out to 51,535,25. Can you remember that? 51,535,25. Okay.
Got it.
51,515,35,25. Okay. That is the surface area when I do it with the measurements. Now, if you look at our screen here, when I did it practically, I got 51,733,25 millimeters. I think that's what I got. Yes, that's what I got. Okay, and it was also millimeters squared. Like this one is also millimeters squared. Okay, now that's very close. We're slightly out. We're out by about 200 millimeters squared. That sounds horrendous, but it just means that when we measured, we weren't 100% with our measurement. Okay, and do you remember why? And I'm going to go and look over here. And do you remember the way I cut this? My giddy aunt. Okay, can't cut very well at all. If you look at it, it's not straight at all. So when I did my measurements, I was actually measuring off something that was a little bit inaccurate. So I didn't expect this to be as accurate as what my actual numerical calculation would be. Had I cut it perfectly straight, these two answers would have been absolutely perfect. And that's why I've got a little margin for error. All right, we're really running out of time because the producer just said in my ear that we've got around about 6 minutes left. And we haven't even touched on volume. So, folk, I want to touch on this whole thing of volume and just look at the basics. And then at some stage later on in this whole series, we're going to have to look at volume in greater depth. And maybe we'll do that just before the revision before your examinations. Okay, but we will touch on volume very quickly. Okay. We were talking earlier just before the break about using real things and calculating surface areas and volumes of certain things, surface areas. You can also do the same with volume, and that's what we're going to look at now. So, for example, what you could do is, again, going into your mom's kitchen, get one of these weird and wonderful shaped things and try and calculate how much liquid one would be able to pour into this container, okay? So again, open it, eat all the chips, then tomorrow come back, pour some water in with a measuring jug and try and figure out how much water can be contained inside this unit. And then try and calculate it. And to calculate it, folk, we've got to be able to work with volume. All right. You don't even need big shapes. You can use tiny little shapes. So, for example, you could also use a coin. So you can take a coin and you can say, well, let's work out the surface area of this coin. Let's work out the surface area of the top of the coin, the bottom, and the side of it. Okay? Even a 50-cent piece. And that reminds me of another joke. Where does a 50-cent piece live?
In my pocket.
No. In mid-range. Think about it. 50 cents, mid-range. Okay. Yeah, sure. Okay.
Those are goodie.
That was another one from my cricket boys earlier. Okay, right. Volume. Let's look at it. Simply, volume for a rectangular prism is length times the breadth times my height. So in other words, to calculate the volume, I need 3 different measurements. Okay? I need the length, I need the breadth, and I need the height of that shape to calculate the volume. Simplistically, and this is what I kind of tell my guys at school, volume is actually area times height. That's what it actually is. If you look at this, here's a rectangle. If I drew it like this, okay, and there it is over there, I could calculate the area of the top and then multiply it by the height. In other words, I could say it's the length times the breadth, and then we multiply it by the height. Area, length times breadth, times height. Let's look at this one now. Here's an interesting one, a triangular prism. A triangular prism, if I drew a triangular prism standing up straight, okay, it's a rather sad looking triangular prism, but there it is anyway. What I could do is work out the surface area of the triangle, and to work out surface area, it's half times the base times the perpendicular height. So I could work out the surface area of the triangle and then multiply it by the height of that triangle. Okay, that's volume. Height times the area. All right, and we know what the area is. So I could say now volume is the area, which is half times the base times the height multiplied by the whole height of that prism. Now, this height of the triangle is the actual height of the little triangle, not the height of the shape. Okay? That can be a little bit confusing, but when we look at examples, you'll understand exactly what we're talking about. And finally then, a cylinder. A cylinder is the area of the circle times the height. So we know that the volume of a cylinder is going to be the area of a circle, which is pi, times r squared times the height. Okay? And that would give us the actual volume. And guys, in a nutshell, those are the three main shapes that we deal with when we talk or when we test you on volume at the end of matric. But understand, okay, that's not the kind of question we're going to give you. We are not going to say, calculate the volume of a rectangle, calculate the volume of a triangular prism, or calculate the volume of a cylinder. What we would do, or could do, is this. Let's look at our shape again. We could actually say, you know what, guys? How much water can I put into this container? Work it out. Now, to do that, we've got to calculate the volume in centimeters or millimeters squared. And once we've got the volume, then we've got to convert it and work out how many liters can then fit into that volume of space. Alright? So, it's not straightforward. It's not basic like I've shown you here. But you've got to know the fundamentals before we do this.